So here we go. So the last thing we need to cover is like 5 slides, right?
Yep.
So we've talked about compounds. You use a formula, a chemical formula to describe a compound. You know, H2O is a chemical formula for water. You know, NH3 is a chemical formula for ammonia. Chemical formulas, right? Actually, there are 2 types of chemical formulas. There's the molecular chemical formula, the molecular formula, and to me that gives like more information than the second one I'm going to show you. Okay, so molecular formula is the real deal. You might kind of see the root molecule in molecular formula. In 1 molecule of water, you have 2 hydrogens and 1 oxygen. In 1 molecule of benzene, that we have 6 carbons and 6 hydrogens in 1 molecule. Okay, that's molecular formula. Now, the empirical formula is actually potentially a reduced form of the molecular formula, and sometimes I get these mixed up. So keep me honest here. Keep me 100%. Okay. So an empirical formula, there's some reduction going on. Sometimes not. Whether it's a molecular formula or an empirical chemical formula, the little subscripts need to be whole numbers because they're talking about the number of atoms of each type of element there is, okay? So let me show you some examples of side-by-side molecular formula and empirical formula. So do you remember when we crisscrossed for our ionic compounds? If we were given a cation and an anion, we crisscrossed. And if we got 2s, okay, that on both little subscripts, we had to divide by 2 and leave it as 1 and 1, okay? That's kind of what we're doing here a little bit. If a reduction can be made, you need to go ahead and reduce that to go ahead and get your empirical formula from your molecular formula. But you need to leave it with whole numbers. So do you see where we can divide by 2, okay, to get, instead of 4, it's 2, instead of 10, it's 5, okay? So that's a reduction we can do for butane. But now if we look at water, okay, we cannot divide 2 and 1 by a common whole number and get another set of common whole numbers, a different set of common whole numbers. So its molecular formula is its empirical formula. Okay? That's how that works. And remember, this is going to be extra credit on your test. Okay? This is one of my favorites. Hydrogen peroxide is H2O2. So a molecule of hydrogen peroxide has 2 hydrogens, 2 oxygens. Of course, we can divide those both by 2, and we get 1 and 1. Okay? Ho, ho, ho. The next 2 are actually also my favorite. So I have a pair of hydrocarbons. Oh no, I guess this is the third from the end. Hydrazine, we've talked about hydrazine. It's a molecular compound because nitrogen is a nonmetal and hydrogen is a nonmetal. Okay, so it's a molecular compound. We can reduce it by dividing the 2 and the 4 by 2 and getting 1 and 2 respectively. The last 2 are my favorite. Okay, so acetylene, actually it's that carbon, triple bond carbon, and 2 hydrogens on either side. It's kind of an exciting little molecule. So we can reduce C2H2 and get CH, right? So here's the cool thing too. Benzene, which is a totally different molecule than hydrazine. Okay, benzene and hydrazine, they have some similarities, I guess. They're both hydrocarbons. So in a benzene molecule, we have 6 carbons and 6 hydrogens. Okay, of course, you can divide both 6 and 6 by 6, and you get 1 and 1. So my point here is that even though these are very different, okay, they have the same empirical formula. Okay, so empirical formula. One of my slides coming up is what you guys handed in, which is weight percent analysis. Basically, given the formula of a compound, how much mass is brought by carbon, how much mass is brought by hydrogen, weight percent. Well, can you see in both of these compounds, acetylene and benzene, that they would have the same weight percent carbon and weight percent hydrogen? Okay, I just think it is so cool. It is just amazing. I know, it's the little things, right? So the empirical formula, the reduced form, okay, actually has a link to those percent elemental compositions, the weight percent problems that you did. Okay, we say it this way. Basically, when you guys handed in your homework and said how much weight percent there was of each element in the compound, you were given the relative amounts in mass. When we look at a reduced empirical formula, we're given relative amounts in numbers of atoms. Okay? For acetylene and benzene, they both have a kind of a 1 carbon to 1 hydrogen ratio. So that's what they have in common. Okay, so this kind of says my two favorite ones, acetylene and benzene, you know, C2H2 and C6H6, definitely different molecular formulas, okay? They have the same empirical formula. So compounds with the same empirical formula will have the same percent elemental composition if you were to do the mass brought by carbon, mass brought by hydrogen. Just something to think about. Okay. So the whole crisscross, you know, an ionic compound, and I said if you get a 2 and a 2 here, you got to go ahead and reduce it, right? Okay. So usually ionic compounds, just because of the nature of coming up with the lowest common repeating unit, set of repeating units that works to make you a neutral formula unit, they're usually empirical formulas. I have to get my empirical molecular right. Exceptions are this, and I know that everybody loves the mercury 1 polyatomic cation. Mercury 1 polyatomic cation, Hg2, 2+. Okay? We said that that stays as a unit. Okay, so what this is saying is if you crisscross that with chlorine, and you guys would tell me since chlorine is a halogen, 7A, it picks up 1 electron, it forms a -1 charge. Okay, if I crisscross, okay, I'm going to go ahead and get what? 2 chlorines and 1 of these units. But remember, this is mercury 1. Don't blame me, right? And the cool thing about mercury 1 is it has Hg, covalent bond Hg, all running around with a +2 charge. Okay? Thou shalt not split up mercury 1, Hg2, 2+. Okay, so when we crisscross, of course, writing this, okay, we rewrite Hg2. We need 1 of them. Okay, I could put this in 1 if I wanted to. And we rewrite chlorine, and I put 1 of them. Or excuse me, I put 2 of them, don't I? Yeah. Okay. So we gotta write it Hg2Cl2. Okay. That's the compound's formula. Of course, if we had blinders on and we're going to go ahead and apply what we know about taking a molecular formula and reducing it to form an empirical formula, we would divide each of those 2's by 2 and get HgCl. So that's one exception. Another exception, I had to look at this for a while, and this one really confuses me. Not really. But one of the things you guys are going to need to do on your test is to be given something like this and go left to right looking for the cation and looking for the anion. Okay, so hopefully you guys have spent some time with those polyatomic ions and you recognize from left to right you're looking for a cation. NH4 plus is an awesome cation. NO2, what's the name of NO2? Is it nitrate or nitrite?
Oh,
Nitrite, exactly. Okay, so the name of this is ammonium nitrite. We do not use any nitrous stuff. Those are actually for, if you've been reading your textbook, that's great. But the nitrous stuff and all that stuff, that is for covalent compounds. Did we talk about naming covalent compounds? We talked about naming ionic compounds. You will only use, I think you'll only use di in a couple of places. In a couple of places with your polyatomic ions. That is it. So if I see a bunch of tetras and monos from your test Thursday, I will be sad. So the only dyes I can think of is dihydrogen phosphate. And there's 2 chromium compounds. One is dichromate. The other's chromate. That's the only dyes I can think of. Okay. But my point was that actually, if you combine the nitrogens, okay, you know, we write it NH4NO2 to see ammonium nitrite, right? But you could combine the nitrogens, and I'm probably spending too much time here. You combine the nitrogens, and you actually get N2H4O2. Does that make sense? into H4O2. And here now we could go ahead and divide by 2, okay, to get a reduced empirical formula. Okay, but we definitely would not, that's not the formula. So those are 2 exceptions. Okay, so these, I didn't pull them up, but you guys have them handy, hopefully. Well, let's make 80.
We already did them.
But you didn't do this part. Yeah, somebody, I wasn't looking ahead very closely on Monday's lecture, but actually this is asking you to do something else. So basically take these formulas, and this is one that you have to do. This is due when you come to take your test. And this is optional. And it will be worth 10 extra credit points. Some of you guys need to sell your extra credit points on eBay. Okay, are there any questions about that? Okay, good. So